Welcome back to what I'm increasingly thinking of as the podcast of Dorian Gray. And shut up, I keep calling them podcasts because I am old. I actually had to ask my 7-year-old daughter to explain to me how on YouTube, like videos apparently, or vids, they come in episodes, and if you have a bunch of episodes together, this is a series. So this is a series on dplyr. And this is the seventh, I believe, in the. It is the seventh. She says, scrolling back to where she's was up to the seventh in a long series of sections that introduce different parts of the dplyr package. What you should have noticed, I hope, if you've done the exercises from the end of part 6, is that essentially the exercise for part 6 was actually to do the things that I was doing during the bind rows section. So hopefully that has gone fairly well, and you've got the answers to that. What we're now going to do is talk about pivoting. And pivoting is essentially a way of reshaping your data. And what I find with pivot, or the pivot data analysis functions, yes, she says catching her mistake there nicely, is it helps to start simple. So rather than use the small world of words data, what I want to do is start with a really, really simple data set, just a toy data set to illustrate what I mean when I talk about reshaping or pivoting a data set. So what I'm going to do is start with some lovely data, a lovely small data set called data love. So we use read CSV from before to read it into a tibble, which we're going to call love. And the love tibble has 4 rows and 3 columns. So there are 3 variables there: color, heart, and book. And what you can see is that this is a data set that shows you 8 different emojis. So there are 4 colors: blue, green, orange, and yellow. And there are 2 types of emoji: heart and book. And so it's just printing these emojis in a nice little 4x3 table. What I might want to do is organize this data in a different way. So, for example, I'll just jump straight to the conclusion. Have a look at the table here on the right. Don't worry about the code for a second. The same information could be written a different way, right? So here is an 8x3 table that has 3 columns here. So color, object type, or just object, and emoji. And so for the blue heart emoji, you get this lovely picture. For the blue book emoji, you get this picture. The green heart, you get this one, and so on. This way of organizing your data is called long form, because there are more rows and there are fewer columns. So if we go back, this is what we would think of as wide form, because there's sort of there's the exact same number of columns, but usually there would be more. I really thought this one through, didn't I? But the key thing is, this is the same information. It's the same 8 emojis organized, where we've just got one color, one variable here that picks out the color, and then you've just got heart and book as separate columns. Whereas what we do in the long form is all the heart and book emojis are all in one column called emoji, and what you've got is an indicator variable called object, which specifies whether this is a heart or a book, a heart or a book. And so that's the gist of what we're trying to do. So to go from this data, which is in wide form, what we want to do is pivot it to be in long form. So we go like that. Yeah. Okay. So the command we want is called pivot longer. So there are 2 functions: pivot longer and pivot wider. Pivot longer takes a wide form data set and makes it longer. And so what we need to do when using pivot longer, and I'll go through this in a moment, bit by bit, is firstly we need to specify 3 things. We need to say what are the names of the columns that we want to pivot. So we want to take, let's go back, the heart and book columns. Where's our picture? There we go. So the heart column and the book columns are the ones that we want to take and stack on top of each other. So those are our columns, Then what we have to do is say, okay, what the names, that is the word heart or the word book, do we want those names, what variable do we want to store them in? So we say that the names go to object. And that's going to create a new column called object. And where do we put the values being the emojis themselves? Where do they go? Well, let's put them in a column called emoji. So these two, the names to and the values to arguments are used to specify what are the variables that we're creating. And I'm going to create an object variable and an emoji variable. And the object variable is going to store the names, and the emoji variable is going to store the values. Okay, easy enough. If we do that, we get this as our output. Okay, let's see if we can recreate that, if I am smart enough to do this myself. And it's not obvious that I will be, because the pivot wider and pivot longer functions are relatively new, so I am not used to using them. I used to use a set of functions called gather and spread, which were very similar but had a slightly different structure to them. So this is going to be an interesting exercise to see whether or not I can remember what I'm doing. Alright, so step one is going to be, let's load the data. So over here on the right in the file pane, we have the data sets. So we've got read CSV, and what I want to do is get data love. I am really mastering this use of my mechanical keyboardy thing. I think it's a mechanical keyboard. Okay, so yep, it's done that. It's parsed it with column specification blah blah blah. Love is emojis. Yeah, okay, cool. So now what I want to do is take this emoji, this data frame, which I'm just going to put to the top again by going like that. Okay, so I want to take that, and now we're going to pivot it. So we go pivot, yeah, that'll work. Pivot longer. And so we're first saying, what is the thing that we're going to pivot? This is going to be the data. So we can either, and this is a little bit of a reminder, I can either do this, data equals love, so that's where we're taking it from. Cols equals, yeah, that's clever, equals, so what did we say the columns were? We were going to take the heart and book, right? Comma, book. Okay. So now what I need to do is say, I could specify the names to and values to, but for the moment, let's just leave it like that, okay? This is the minimal version of a pivot longer statement. So if I do that, what we've done is we've taken the love data, and what we've done is grabbed the two columns heart and book, and we have stacked them on top, their values on top of each other in a value column, and we've taken their names and stacked them on top of each other in a name column. Now I could have done this in other ways too. So as again a bit of a refresher or a reminder of what the pipe is doing, if I just delete that data equals and go love and Control Shift M to give me my pipe in there, if I go love goes to pivot longer using columns heart and book, again that gives me the same answer. So as a little bit of a refresher, the pipe is essentially being used to take whatever's on the left hand side of the pipe and push that in to the function, in this case pivot longer, and we're using that as the first argument to it. So I'll go back to using piped code. Okay, but it's nice to have a little refresher to remind us of what we were doing. I'll clear the screen again so that we have the cursor up the top of the video, and let's go back to our command. So we've got love, we've piped love to pivot longer, and we have used columns, heart and book. And so now it's a little clearer what the names pattern Sorry, I'm good at this. Names2 equals names. I'm going to get an error if I don't fix that. Okay, so names2. And what did I want to call it? I think I wanted to call it type? No, object, I think is what I called it. So if I did it just like that, you can see it's the same output as I got before, but now the name of the names column has been renamed as object. Yeah, that's great. You get the idea. So I've gone names2 equals object. If I want to do the same thing with value, let's go values2 equals emoji. And it just drives me nuts when things wrap like that, so I'm just gonna, okay, go like that. There we go, that's better. So now we've got love, we're piping it to pivot longer, we've got the columns that we're going to pivot are heart and book. The names are going to go to a variable called object, the values are going to go to a variable called emoji, and that's what we've got. Okay, cool. So we've got most of the code from the previous version. All I want to do is have a variable here. We'll call this longlove, and I'm trying very hard not to make inappropriate comments, so I will simply control myself and go Control L and go, we now have a variable called longlove that has our data in long form. And in a moment, after going through it in the slides, we will talk about how to pivot that to a wider form. So let's go back to my slides. Shockingly, the function to take a long data set and make it wide is called pivot wider. So we've got long love, that's the variable I just created. Pivot wider, and again you're going to tell it which columns to pivot. So we're going to take which column is the ID variables, and what that's really saying is which ones do we want to keep in their current form. So that is the color variable. If you remember from before, color, rather than force you to rely on your memory, color stays the same. In the wide form, color is just blue, green, yellow, orange. We're not doing anything to it other than leaving it as it is. But if we look at our other two variables, object and emoji, we're going to pivot those two into the heart and book variables that we saw in the original version, right? So color is called an ID variable, which is essentially means it's an identifier, or very often in psychological context, those tend to be between subject variables, but not always. But ID variables are those that remain the same or remain where they were when you go from long form to wide form. So, okay, so we've got ID columns, and that's going to be color. And then what we have to do, we go back to our longlove variable. Which of these two is going to be the source of the names? And that's going to be object as the source of the names, and emoji is going to be the source of the values. So that makes sense because that's when we went longer, we said the names went to emoji, to object, and the values went to emoji. So when we go back the other way, we've got arguments called names from and values from that tell you which variables we wanted to do. And shockingly, that gives you the right answer if we're smart enough to do this the right way. So now we should find out whether I'm smart enough, because, as I said, I am a bit of a novice at the use of these pivot functions. They're not ones that I have used before. So let's Control L. Okay, so we have longlove, that was our variable, and we want to pipe it to pivot, and we'll grab pivot wider, and conveniently it's telling us that so we need ID columns, and for that it's just going to be color, Now, this won't work, this won't be enough on its own, I don't think. It's not. Good. Because pivot, unlike with pivot longer, where you can sort of work out just from the columns alone how to reshape the data, it's not obvious to R how it's going to do the reshaping. So we need to specify the other two arguments here. So if I go names from, and I say we're going to take the names from, what was it called again? I think it was object. And again, let's just see if that works. It doesn't. It's still not convinced that it has enough information for that to work. We go values from, and we take the values from, what did I call it? Emoji? Emoji? And voila, we get the original dataset back. So that's how you pivot a dataset from wide to long and how you go from long to wide. I tried to pick this simple example with the pretty colors and pictures so that you can kind of at least visually see how one of them is the other one stacked on top of each other, kind of like I'm showing you with this terrible hand gesture. But if we kind of put the two side by side, you can kind of see how that is exactly what's happened. I've taken the wide form and they're just stacked on top of each other. So it's like, and very similar to not dissimilar to what we were doing with bind rows. It's a kind of stacking and unstacking operation. It's just a different way of doing it. Okay, so that is kind of the simple version of how to do pivoting. Now what we want to do to end this section is to kind of go back to our real data, and we're going to just take the take our gender data frame, and what I'm going to do is just grab the forward associations only, and then I'm going to pivot those to a wide form. With what I want to do is take the associate as our ID variable, the word is where the names are going to come from, and the values are going to come from rank. And that's going to give us this kind of tibble. So the associate is going to stay the same because it's an ID column. So that's just telling you what is the word to which woman or man is associated. The name come from words, so that gives you woman over here and man over here. So the word is indicating which thing is being associated to. And the values are just the ranks. So what you're seeing in the output here is, in the first column, female is the second strongest forward associate of the word woman. It doesn't appear anywhere as an associate of the word man, so that is na valued. And na or na is short for not available, and what it signifies in a data analysis context is missing data. There is no rank known for female for the man associate. In other words, when I said man in the experiment, nobody said female as the response. And so you're seeing missing values over here and missing values over here. So there are some words, well, one I think in total, strong, that appears as an associate of both man and woman. It's not a highly ranked associate, but it is nevertheless a forward associate of both words. Okay, so I will, again sticking to my previous practice, try to do this in the script. So let's do, again I will create a section, remembering to use my keyboard. So let's go, where will we go? Pivot forward associations. Okay, so we're going to go gender, and I'm going to pipe it to filter. So we're just going to have, I've forgotten what the variables were again. I think it's don't mind me. I'm hitting the wrong thing again. Filter, I think it was type, right? I was calling it type. Let's just check this again. You probably know this because you've got the slides right in front of you, but I am brainless. So I've gone gender. That is so annoying. Okay, so I think I called it, yes, type. Okay. This is extremely common when programming. You forget what you were doing and you have to keep looking back at stuff. So we go filter, type, equals, and for once in my life I will be smart and remember to do the double equals when filtering. Type equals forward. Honestly, more often than not I forget that. So again, we're going to pipe from there, and then we're going to go pivot, and I believe I was pivoting wider. And let's just do this on a different row. So the ID calls, there's only one, and that's going to be associate. And then we go names from, and I think it was word. And why would you do this to me? You don't love me, do you? And then we go values from, and there's a part of me that really wants to type emoji because that's what I did last time, but that's not the right answer. The right answer would be rank, I believe. Okay, so let's try that. I'll save it. We'll source the whole thing, and it's not going to print anything because I am a bit dumb. What I need to do is if we just go Control Enter, there we go. And that gives us the exact same thing that you saw in the slides. So male is an associate of man but not of woman. Husband is an associate of man but not woman. Female is an associate of woman but not man. Okay, so that's the gist of how we do this. Let's save it in a variable called gender forward. And let's do another little exercise. So first I'm just going to do that, and I'm going to very, very quickly pivot. So flick back over here to my slides, and I want to do some cleaning up. What I would like to say is I want to replace, I want to take the values. So let me start that again. What I want to do is clean this up a little bit so that I do the following steps. First off, for the woman variable, I'm going to take I'm going to replace the na values with 0, and I'm going to replace everything else with 1 over whatever its current value is. And for man, I'm going to do the same thing, and then I'm going to create a difference variable between the two, and then I'm going to arrange it by diff. That is not immediately obvious, I suspect, for you seeing it right now. So a little exercise before we continue is trying to think about, to see whether you can understand what I'm doing here. I'm about to do it again, I promise, so that you won't I'm not going to throw you into the deep end completely. But here's what we've got. I want to take the value of woman, and I want to go 1 over that. So if we go back over here, so for those things that used to have a value, so we said female was that was a thing that did have a value for woman, so it had a rank of 2, and so I've just gone 1 over the rank. This is crude, and it is not necessarily the best data analysis strategy, but what I've got here is something that is larger for strong associates and lower for, ironically, weak associates. So 0.5 is the strongest associate in terms of rank order. So female is the highest ranked associate, strong is the weakest ranked associate, and then all of the things that were missing have been replaced with zeros. So if we go back here, that's what replace na is doing. If it wasn't uh, um, we've taken the value of 1 over woman, and anything that was missing we've replaced with a 0. So over here we've taken the value 1 over man and replaced it with 0, and then I've used that to create new woman and man variables. Remarkably, somehow within the same mutate statement, it is possible to use the results of these computed outcomes. So I have created new variables woman and man that were different to the old values, and I can construct a difference between the two within the same statement. So that is kind of a handy property of the mutate function. And then I can arrange it by the difference, and that gives us these things. So let's go through this ourselves. So we can take the same thing, and I'm going to go pipe that again, and I'm going to go mutate woman equals replace. So we're going to take the old value of the woman variable, and we're going to do a replace nah. And so here's what we're going to do. We take the 1 over the old value of woman, and anything that was missing we replace with 0. Okay. Do the same thing for man. So again we go, so a new variable man is being created where we take the replace, so we take the replace now with 1 over man 0. That's the thing I was trying to show you before in the slides. I'm just going to go show you this first, just to convince you, or at least make you believe, that I have done the right thing. And convince myself too while I'm at it. So we go gender forward. You can see that it has created the same variables. I personally find it is more helpful when trying to understand what's going on if we go over here and think of it like this. So one thing I want you to notice is that you can actually use the pipe inside a mutate statement. So if I take 1 over woman and then pipe it to replace like that, to the replace now, and 1 over man like that, I think you get code that makes a little bit more sense. So let's go over here and do the same thing, and go add our little pipe operator. So now what you've got is a mutate statement that says, okay, the new value of woman will be 1 over the old value of woman, where, like then, we'll replace all the nar values with zeros. I find that easier to read in most cases than the version that I've just shown you. I have shown you in the slides. I usually write my code like this, but I wanted you to see that these are the same operation and you can use pipes inside mutate. That was really the point of that little digression. Okay, so now if we go, now we're going to go diff is going to create a new one, and I'm going to call it woman minus man. Okay, so this is going to be the same thing, and we'll go Control Shift S, run the script again, bring that up, clear my screen with Control L, and then go gender forward, and we get something that is not quite the same. Why is that? Probably because I'm stupid. I'm wondering if the correct answer is this. This might be one of those moments where my attempt to be clever has backfired against me, and so I'm putting some parentheses around there, and let's just see if that solves the problem. Gender FWD. That gives us the right answer. Okay, so I'm going to pretend that I did that on purpose. Sometimes when I make errors in these things, it is on purpose. That one was an accident because I forgot about something that actually matters. But it's a useful accident because it's a thing you need to know. Okay, what order does R do things in? When I typed it in like this, the pipe operator has what's called high precedence. In other words, R does this thing first. So what it does, when I do this, when I typed 1 over woman pipe blah, what R has done is done it in this order. So anything inside the brackets it does first. So it's gone woman, tried to replace anything that was missing with zeros, and that works. You can do that. You can compute, 1 over. You can do this. It'll just go, okay, well there were missing values. It's replaced it by 0, and then it goes 1 over that. 1 divided by 0 is infinite. And so that's why, when I made that mistake previously, which of course I've deleted, why don't I just leave the code like this and run it again? So we'll go save that, run the code in the current form. So notice that this version has the brackets around woman pipe to replace na, and this one has the brackets around 1 over man. So this is going to compute 1 over man first, and then pipe the results of that to replace na. And we can notice the difference in the outputs. If we go gender forward, in those cases where I was trying to replace the man variable, I got the right answer, right? Because I did 1 over man first and then replaced any missing values with 0. For the woman variable, on the other hand, I made the mistake and I've done things in the wrong order, and so I've got the wrong results. So I better go back and fix that up. As a general rule, if you're never sure what order R is doing things in, the easiest solution is almost always just wrap whatever things you want to happen first, you can wrap them in parentheses. Parentheses always happen first, so it'll do everything inside this parenthesis, and then it'll do everything afterwards. Okay, so now we go like this. Control L, let's have a look, and go gender forward, and we have the right answer. Cool. So now I go back to my slides, and then what I want to do is a ggplot. So I will go back to my code. This is now for you a bit of a revision exercise to try and remember from what we did previously. So I'd better see if I can remember this. So here we go. We go ggplot, and I am again going back to doing the wrong thing. So we go data, ggplot data equals gender forward plus, I'm going to go gmcol. Okay, so we're going to have columns, and what I want to really plot is the value of the difference. So we're going to do a column plot, a bar plot. So like before, the height of the bars is going to be on the y-axis. So the height of the bars is the difference. So this is basically the difference in associative strength for woman versus man. And on the x-axis, we're going to have the word itself, so the associate. And let's just start with that. That's not the whole of the plot, but it'll start. What have I done wrong? Okay, we have to pause and go, oh, that's why. I have made the same mistake that everybody makes. Um, Once again, this is a mapping. If I want to map a variable in my dataset onto a property of the plot, I need to put it inside an AS call. So, here we go. Okay, this is not quite the same as the plot that we got previously. You can see that it gives us some things, right? So, girl is more strongly associated with woman than man. That makes sense. Male is more strongly associated with man than with woman. But these are not ordered in any sensible way. And it's also annoying to have to kind of draw the plot like that. Previously, what I did, I'll do it again here. So we'll go another plus statement and go coord flip. We've seen that before. So now let's go and grab these selections. We run that. Now that's given us let's flipped our x and y axes about, so that's kind of nice. What I would like to do now is reorder these columns, right? So these rows, associates, these things, I would like to have them in order of strength. The way that I do that is to reorder them inside the data, inside the mapping statement. So what I want to do, let's go like this. Firstly, give myself a bit of room in my coding. This is just the same thing. Instead of having the associate, the word itself, in its own order, what I want to do is do what I said, remember before? I'm not entirely stupid. I did introduce you to this trick before, that you can use the pipe inside other functions. So I sort of lied. It actually was a deliberate mistake. Ish. Okay. Anyway, so we take the and what we want to do, we take the associate variable and we go reorder by diff. So now on the x-axis, it's going to plot the associate, the value on the, what was the x-axis before we flipped it, what will now be the y-axis. We're going to take the word associate itself, and reorder them by the value of diff. So that, when we go like this, gives us our nice pretty plot. Okay. And that now gives us the ability to look at the difference between what words are associated with woman and what words are associated with man in the forward association sense. And over here, I might as well wrap this up with a bit of psychology. The forward associations are fine, right, in terms of whether they are, good, bad, or nasty. Like, really, female, girl, lady, wife, me, beauty, as associates of woman are reasonable choices. They don't seem to be particularly weird, or they don't seem to be particularly asymmetric or unusual. Picking the right words here. Male, human, husband, boy, gender, person are slightly more associated with man than with woman. That's mostly innocuous, though not completely, right? Human is more strongly associated with man than with woman. That's not great. Like, if you were looking for hints that maybe there are some sexist assumptions built into the structure of language and how we think in words, there's a hint right there that men are considered human in ways that women are not. Like, you are quicker, faster, more willing to associate man to human than you are to associate woman to human. That's there in the data. In the forward associates, that's probably the worst example I can find, like of the most obvious piece of sexism that's built into the language, but there is definitely more that you can find if you go digging into this data more. Which brings me to, there's the plot that I just drew, the thing that will be your final exercise for dplyr, which will be to do the same thing with the backwards associates. So I will leave you to do that, and you can decide for yourself whether there are some differences between the words that are used to describe women or are strong associates of woman versus the words that are strong associates of man in the backwards association. I will leave you to do that, and we'll be back in just a moment for the final installment of this dplyr series, and it will be relatively short compared to these other ones. Okay, good luck!